Hello, welcome to week 11's class. Last time we talked about entropy rate balance equation for a closed system. So naturally our next topic is entropy rate balance equation for a control volume. First of all, let's recall what was our equation for a closed system. If we have a closed system, then entropy rate balance equation is derivative capital S over dt equal to sigma j from 1 to n q dot j over tbj plus sigma dot. This is the entropy rate balance equation for a closed system. And if we have a control volume, what will be this equation? The left-hand side will still be the same, derivative capital S over dt. And in the right-hand side, we will still have heat transfer, sigma j from 1 to n q dot j over tbj plus sigma dot. And in addition to the two terms in the right-hand side, we will have two more terms. What are they? We will add one more term, which means the entropy brought in at the inlet. When mass comes into the control volume, it also brings in entropy. So plus m dot I Si. M dot I is the mass flow rate at inlet. Lowercase si is the specific entropy at inlet. And then we do the same thing for the exit, minus m dot E Se. M dot E is the mass flow rate at the exit. Se is the specific entropy at the exit. And then what if we have multiple inlets and multiple outlets? We can just sigma everything up. Sigma up all the inlets and sigma up all the outlets. This is the entropy rate balance equation for a control volume.